In the previous class, we are discussed about the diffraction pattern. So, the graphical representation, how it forms the maximum, central maximum, and a secondary minimus and maximus. So, in this class, just we are going to combine these interference pattern in case of the double slit experiment, and in case of the diffraction pattern in case of the single slit experiment. So avoid the combination, just we are going to compare those two. Okay. So in case of the interference pattern, ನಮಗೆ interference pattern ಅಲ್ಲಿ ಯಾವ ರೀತಿ ಗ್ರಾಫ್ ಅನ್ನು ತೋರಿಸಿದೆ ಅನ್ನೋದನ್ನು ನೋಡೋಣ. First here we have taken the intensity along these y-axis and the fringe width is along the x-axis of force. It is the intensity. So here this is the intensity. Okay. So in case of the double slit experiment, so here what we know that at the central position it is very bright we get. So in case of the a double slit experiment, at the whatever the center position of these is two slits is there, in that position superposition of the waves has to be takes place. Those will phase difference is 0 and we get the bright fringe. Okay, so it is the bright fringe. After that the brightness on either side is goes on decreases. Okay, now the intensity has goes on decreased like this on either side of the central maximum. Okay, like this the intensity is goes on decreases, but we know that the fringe width is the same. So for both dark and whatever the bright bands we get, the fringe width has to be same. So here also we shown the same thing. Okay, so this indicates a double slit experiment interference pattern. Now it is a maximum intensity, you can say I not. Okay, now in case of the single slit, how it forms, we get the central maximum on either side, the intensity is very less. Okay, now we can show like this, observe carefully. So this is the central maximum in case of the what, a single slit. Just I drawn the envelope for these. So like this it forms. So at the center position it is what, very bright, on either side it is whatever the brightness we get, it is very small like this. So we get the patterns. So whatever inside we represented due to because of the interference pattern, whatever the graph you get, how the intensity has to be varied and whatever the fringe width we take, this is the central position. Okay, now in case of the a single slit experiment, so just you have taken the envelope of that one, because we know that at the central point we get central maximum, it is a very bright, on either side and the brightness has to be what, very less. Central maximum tumba bright irutte, so on either side remaining it is a very small brightness na namge sigta irutte. So for example, see in case of these whatever the double slit experiment we have seen, so we are seeing the graph like this. So central maxima, after that we have seen like this. But in case of the what, diffraction, you have seen the what, the graph like this. Just we have combined these two and we have shown graphically the interference pattern and envelope of a single slit experiment of the diffraction pattern. Okay, suppose here if theta is the angle of diffraction for the first secondary minima, so in that case the angular width of the central maxima is, suppose here if theta is the angle of diffraction, theta is the angle of diffraction for the first secondary minima, the angular width of the central maximum, we know that theta is equal to what, lambda by A. Theta is equal to lambda by A. This is the angle of diffraction. Here what they told for the secondary, first secondary minimum they asking, means the theta is equal to 2 theta is nothing but a 2 lambda by A. So this is the angular width of the central maxima in case of the what, the angle of diffraction for the first secondary minima. Okay, in the same way the linear width of the central maxima, linear width of the central maxima is, we know that for that x is equal to lambda d by A, x is equal to lambda d by A, the linear width. So here they are asking for the linear width for the central maximum, that is 2x is equal to 2 lambda d by A. Just remember these two points. Note, for if theta is the angle of diffraction for the first secondary minimum, so angular width of the central maxima is 2 theta is equal to 2 lambda by E. So here the linear width of the central maxima, x is equal to lambda d by d. So for the what, a central maxima, it is 2x is equal to 2 lambda d by A. So lambda d by A, yeah, 2x is equal to lambda d by A. Okay, so next we can see the difference between the interference and diffraction pattern in the next video.